morning, 11th standard. Today we are going to study about the chapter P block elements, in which I am going to repeat the topic which is deleted this year, and that is the important compounds of boron, carbon, silicon, etc. Fine, beta, this is actually a deleted portion this year, but still it is very important, the preparation of borax and silicons. So that's why I'm going to discuss it about this. And now we are talking about the important compounds of boron. So the important compounds of boron, the first one is borax, which is the most important compound of boron, as you can see here, that it is a white crystalline solid whose formula is Na2B4O7 10 water molecules. Means it is a crystallization of water is present और decahydrate. In fact, इसके अंदर टेट्रा न्यूक्लियर यूनिट्स होते हैं आपके B4O5 OH4 and this is the correct formula of borax, ये वाला Na2B4O5 OH4 8 water molecules. This compound easily dissolves in water and it gives the alkaline solution. Alkaline solution kaise? That because after reacting in water, it gives a sodium hydroxide as well as orthoboric acid. Orthoboric acid is again a very important compound. ये soapy touch वाला होता है compound and its formula is H3BO3. When we heat up the borax, it loses a water molecules, obviously because it is a hydrated salt, and then it swells up. धीरे धीरे क्या हो जाएगा? Swell हो जाता है, फूल जाता है ये. And on further heating, it converts it or it turns into a transparent liquid, which gradually or after cooling, it solidify and it converted into the borax bead. इससे ना छोटी छोटी सी beads जो मालाएं होती हैं, माला के मोती होते हैं, उसकी तरह की beads बनती हैं इसकी. And the reaction which is taken place in this one, that is that when you heat the borax, it will gives a sodium metaborate Na2B4O7 after after losing of a water molecule, and then at last it converted into the NaBO2 plus B2O3, that is known as the boric anhydride. Now these metaborates जो होते हैं of many transition metals, इनके characteristics colors होते हैं, जो ये यहाँ पर हमें metaborates मिलते हैं, ये वाले, ये इनके अपने different particular colors होते हैं, and because of which it is also used as a borax bead test, which is used in the laboratory to identify the different transition metals. जैसे कि अगर हम बोरेक्स को बंसन बर्नर की फ्लेम में हीट करते हैं कोबाल्ट ऑक्साइड के साथ in a loop of platinum wire, then a blue color bead is formed. तो कैसी कलर की bead formed होगी? A blue color bead is formed. So different transition elements when heated with the borax in a Bunsen burner flame on a platinum wire loop, and different colors of beads is formed. So that's why it is also used as the borax bead test, and which is used to identify the different characteristic colors of transition metals. All right, the next one is orthoboric acid. As I have already told you that this is also a very important compound with soapy touch. It is sparingly slightly soluble in water, but it is highly soluble in hot water, and its preparation is by when we acidify aqueous solution of borax, ठीक है, HCl मिला दिया और water मिला दिया उसमें, then we obtained a orthoboric acid, BOH whole thrice, and it can also be prepared by the hydrolysis a reaction of boron halides, boron hydrides, etc. ठीक है बेटे, इन सबसे हो सकता है ये. It has usually a layer type of structure. As you can see here, इसका कैसा structure होता है? Layer wise. It has a layer structure in which BO3 units, ये वाले units जो होते हैं, in which, just 1 minute, these BO3 unit, these BO3 units, that is joined by hydrogen bonds. Like you can see here, देखो ये वाला BO3, ये ऑक्सीजन इसके साथ आपका ज्वाइन हो रखा है. ये देखिए, दिस वन, ये इससे ज्वाइन हो गया. ठीक है, दिस वन ऑक्साइड BO3 का एक ऑक्सीजन इस हाइड्रोजन से ज्वाइंड है, एंड सिमिलरली this oxygen is also further joined with the hydrogen. So these are joined with the hydrogen, we can say, bonds. And as you can see here in the figure, boric acid beta, it is a weak acid basically, monobasic acid, because BOH3 एक OH जो है इसके अंदर होता है, और वो हम कैसे बोल सकते हैं कि because one, as you can see that it is not a protonic acid, H positive ions नहीं release करता, but act as a Lewis acid. It act as a Lewis acid. How it act as a Lewis acid? Because it accepting electrons from hydroxyl ion from here. देखो अब जब BOH3 को water के साथ किया गया है, so it is forming OH one hydroxyl ion and forms BOH4 plus hydronium ion is formed. Whereas on heating, these are the chemical properties of orthoboric. Orthoboric acid above 370 Kelvin, it again forms metaboric acid, that is HBO2, and further a boric anhydride, on further heating. Okay, next we are talking about the boron, another one compound, and that is the diborane. As you can see here in the picture figure also, this is the structure of diborane, and it is the simplest one, boron hydride, and that formula is B2H6. BH3 का dimer होता है बेटा, and it is prepared by, as preparation यहाँ पे देखिए, that when boron trifluoride reacted with lithium aluminium hydride in the presence of diethyl ether, then it forms diborane. And diborane, basically it involves the oxidation of sodium borohydride with iodine also. Okay, and this is the about its structure, in which we can say that the four terminal, 1, 2, these are the four terminal, 3, and this one is the 4. So these four terminal hydrogen atoms and 2 boron atoms, ये वाले बेटा, 2 boron atoms that lie in one plane. ये एक ही plane में lie करते हैं, whereas these 2 hydrogen which are center 2 bonds, ये हो गए ना, दो bonds बन रहे हैं, central 2 hydrogen atoms हैं जो आपके, these are lying in another one plane, और इनको हम क्या कहते हैं? These are also known as bridging hydrogen atoms. ये हमारे क्या हैं? Bridging hydrogen atoms. Now we are talking about the properties of it. So sodium borohydride, when react with iodine, it gives a diborane, B2H6. It is also prepared by reaction of boron trifluoride with sodium hydride at a particular temperature. And if we are talking about the physical properties of diborane, then it is colorless, it is a highly toxic gas with a boiling point of 180 Kelvin, and diborane catches fire spontaneously upon exposure to air. ये बहुत जल्दी बेटा fire catch करता है, and it forms boric anhydride along with the release of a few small amount of energy. ठीक है, हायर डाइबोरेन्स जो भी होते हैं, These are highly flammable in air, and boranes are easily hydrolyzed, means react with water and give boric acid. As you can see, B2H6 when react with water molecule, it gives boric acid. Alright, diborane easily undergoes cleavage reaction because it acts as what we can say Lewis acid and react with the Lewis bases to give borane adducts. ठीक है, BH3.L इसकी तरह देते हैं कंपाउंड. जैसे अगर हम कह रहे हैं ट्राइमिथाइल अमाइन के साथ ट्राइमिथाइल अमीन के साथ रिएक्ट कर रहा है, ये है, सो इट विल गिव्स BH3.NM3. ठीक है, ये बनाएगा. और ऐसे ही आपका अगर कार्बन मोनोऑक्साइड के साथ कर रहा है तो BH3.CO बनाएगा आपका. So these are the different one adducts it is forming. Then ammonia then react with the diborane, so it will gives a as a BH2 NH3 whole twice BH4, जिसको कि आप further heating करें तो हमें क्या मिलेगा, इनऑर्गेनिक कंपाउंड्स. और इसको इनऑर्गेनिक बेंजीन या बोरोजीन भी कहते हैं. क्या कहते हैं, बोराजीन और इनऑर्गेनिक बेंजीन. So it is also very important compound. Now we are talking about the important compounds of carbon as well as silicon. So if we are talking about the carbon, so carbon is having the two oxides, carbon monoxide and carbon dioxide. आप फेमिलियर हो इन दोनों से ही काफी. अगर कार्बन में लिमिटेड सप्लाई ऑफ ऑक्सीजन किया जाए तो कार्बन मोनोऑक्साइड ऑन हीटिंग इट इज प्रोड्यूस्ड, और स्मॉल स्केल में कार्बन मोनोऑक्साइड इज प्रिपेयर्ड बाय द dehydration of formic acid, methanoic acid, in the presence of concentrated sulfuric acid. Again, it forms carbon monoxide. Whereas if we are talking about the commercial scale, large scale पे करेंगे तो carbon monoxide is prepared with the help of a synthesis gas method, in which carbon when treated with water at 473 to 1273 Kelvin, it forms water gas, carbon monoxide plus H2 gas. Whereas air, if air is used instead of steam, um, here then producer gas is obtained. Instead of carbon monoxide and hydrogen, the product which is formed, that is carbon monoxide and nitrogen gas mixture, which is also known as a producer gas. And both of these, water gas and producer gas, are very important industrial fuels. ठीक है, it is also these monoxide, this monoxide ko if we treat it with for the further combustion, then we can convert them into the carbon dioxide. But carbon dioxide के बारे में हम बहुत डिटेल में बात नहीं कर रहे हैं, because you have already studied lots of properties regarding carbon monoxide. So I'm moving up to the silicons here. Now silicons are basically the group of organosilicon polymers, okay, जिनका की फॉर्मूला क्या होता है, R2SiO. This is the monomer, or this is the small unit which repeat itself again and again to form a polymer. All right, the basic material for the preparation of silicon is nothing but it is the alkyl or aryl substituted silicon chlorides. This is a main formula of silicons, that is Rn. N number of alkyl group SiCl 4 minus N, जितना भी R होगा उसको 4 में से माइनस कर देंगे, that will be the formula of SiCl. ठीक है, where R is the alkyl or aryl group. For example, the methyl chloride when reacts with, here please just have a look here, react with silicon in the presence of copper powder at particular temperature, that is 570 Kelvin, then it is forming dimethyl silicon chloride. ठीक है, on hydrolysis of this compound, hydrolysis करने पे इसकी डाइमिथाइल सिलिकॉन क्लोराइड की आपको क्या मिलता है, डाइमिथाइल silicon hydroxide with the release of two molecules of hydrogen हाइड्रोजन क्लोराइड और हाइड्रोक्लोरिक एसिड। सिमिलरली अब देखो बेटा, जब ऐसे ही दो या दो से ज्यादा मीन्स व्हेन टू और मोर देन टू थ्री मॉलिक्यूल्स ऑफ a dimethyl silicon hydroxide polymerized together, combined together, then a क्या होगा, a molecule of water is released from here। ये देखिए, ये यहाँ से ऐसे रिलीज हो जाएगा, प्लीज जस्ट हैव अ लुक। ये एक H और एक OH निकल जाएगा, और जो ये बॉन्ड है आपका, मैं बताती हूँ, ये सीधा ये ऑक्सीजन जो है वो सीधा आपका कहाँ चला जाएगा, ये इस पे आ जाएगा। ठीक है, तो ये यहाँ बना, और ये देखिए यू कैन सी यहाँ पे एक ऑक्सीजन आया है और यहाँ पर एक ऑक्सीजन आ गया। दिस इज अ बेसिक यूनिट फॉर सिलिकॉन्स। ठीक है, तो ऐसे ही यहाँ पर भी सेम यही चीज होगी कि ये एक हाइड्रोक्सिल ग्रुप, एक H, ये रिमूव हो जाएगा, और ऑक्सीजन जो है वो डायरेक्टली आपका इसके साथ सिलिकॉन के साथ जाके जुड़ जाएगा। ठीक है, सो इन दिस वे हम एक बहुत लंबी चेन फॉर्म कर सकते हैं, एंड दैट इज नोन एज द सिलिकॉन। जैसे कि ये देखिए, इसमें पॉलीमराइजेशन हो रहा है, वाटर मॉलिक्यूल हर एक फॉर्म में क्या होता जा रहा है, रिमूव होता जा रहा है, एंड इट फॉर्म्स अ basically silicon. So the chain length of polymer that can be controlled by adding the fixed numbers of trimethyl silicon chloride which blocks the end. लास्ट में हम क्या ले आएंगे, इसको ले आएंगे एंडिंग करने के लिए, यहाँ पर एड ऑन करेंगे इस कंपाउंड को, सो दैट कि हमारी सिलिकॉन की चेन क्या हो जाए, रुक जाए। ठीक है, so this is all about your silicons and important compounds. So please just go through the book also. We have completed all the deleted portion. Thank you.